Testing, testing. Welcome, Michael Wickerson at Wickerson Studios. I'm just going to show some easy methods for generating scripts in Grasshopper for Rhino that are pretty random, pretty creative, and we're going to do that with GPT-4o, and we're going to put in some information description that might be helpful. And I'm going to focus on tessellations from image prompts, and I've got a bunch of these online at wickersonstudios.com if you're interested. But they basically make single nodes in the math node editor right here that you pull down, and you'll probably work in Python 3.0, but you can work in C, you can work in IronPython, but that's the node editor we're going to be playing around with. And then I just title it, and I change this from the Python node to a matching the title of the script to the title of that node. And then I'll show you how to put in some input parameters and make things parametric from the hard-coded script. But where will we start with? Well, we have a script here from the past project, and I'll probably go in and select it all and delete it and run it empty. And now you'll see there's really nothing running. There's nothing in the script here. I've got this on, I think, monochrome, pen and ink, Arctic, and technical. And I'm waiting to see what geometry comes out. I like to output my outputs as kind of lines, surfaces, and solids sometimes. But if I get a good set of lines, I'll probably put it through a multi-pipe. And if I get a good set of lines, I might even put it through a loft if they're separate to build some further geometries. But I keep these nodes fairly light. And let's just jump into GPT 4.0 right here. And I've made thousands and thousands of scripts. Basically, I'm image prompting with the style of a script that I had going that seemed to be working. So I can just grab this, and let's see what we want to do. We basically want to manipulate the complexity of the script that looks more like this image upload. So let's put that in. And we're just going to grab another tessellation. You can make your own, you can draw your own, or you can go online and grab some basic tessellations. And as soon as you get an image in there, you can put the prompt in. And it's wise enough from the past node and the past script to convert that over and write a pretty thorough Python script that might articulate this drawing. And I should give credit wherever I found that online, but I think it's just a math tiling tessellation Instagram page. There's so many sources, and lately I've been drawing my own and uploading them on graph paper, which I think provides a little bit of authenticity. We might have some trouble with the torus, but you can see we're going to use Rhino geometry at RG and a math node. We're going to produce a torus. There's going to be some variables, grid size, grid spacing, and number of grid lines, and it's going to output curves as part B. So it's not outputting A or anything else or C. So let's just start with that one, and let's place that into the tessellation 14 and run it. And of course, in running it, it is going to hesitate, and it generated some things. It generated 531 curves. So let's take off the Control X. Let's take off the multi-pipe. Just look at the curves, and you realize that nothing's coming out of A and nothing's coming out of C because our script only output the B curves. And let's take a look at the magic of what it made. And there you go. Let's zoom extends all. And there you go. You've got a pretty interesting script to start with, and that was just using a image prompt in a very fast way that allows you to then, if I wanted to, I could put it in here. It's going to become pretty ugly to look at. And there it is. Actually, not bad. That is a pretty beautiful script. And if I went in there and took a look at the top view, I could bake that out. And in a very fast way, using an image prompt, I'm able to have access to some pretty cool geometry. And there it is. I'll take my grasshopper off. And I would hate to have made that from scratch. So we'll go in here and make it monochrome. And there you go. Got a pretty wild script that you can Control Shift and turn into other dimensions. And that was generated by a basic image prompt. It is that easy. It is that fast. And that is the magic of working with GPT-4 image prompting into incredible models that you have to lose a little bit of control. What I will do to tidy this up in the end, for those that want to go intermediate or more advanced, I'll go in here and I'll take a look through here and I'll say, okay, grid lines is a float. So I'll copy that and I'll put this over to a typeset that I had at radius, which was set to a type hint float. And now I know that one wants to be up around 40, so I'll just take that node. And of course, I probably should lock this solver while I'm doing this. Let's set that to 40.0. So I've got a nice slider that'll go to grid size. And of course, the script's not running now. I've locked it with my scroll key. I've got grid spacing, so that's at 10. I will name that grid spacing, and that's a float. And then that's all I want to be parametric. So I will hashtag out that comment for grid size and grid spacing. It defaults to these inputs. I can log off my solver. There we go. I can close this. I have a geometry that was baked, but I have a parametric model that I can eliminate these two from the last script, and I will take them off. 31 milliseconds to run because the script's fairly long, and there you go. You got a nice little parametric model of grid spacing and grid sizes, which are basically just nested loops for those that program. And I'm able to change these curves. I'm going to take off this solver here so it'll move a little quicker. I don't need this geometry. I don't need this geometry. I don't need the lofts. And there's my multi-pipe. But I actually think I'll leave it because I may end up using it in a future script. So you're really coding fast and you're modifying furiously. That's what I call this series. And that's it. So we can change the size of that, of what's around it as params, and then we can change also what's happening within it, which is actually pretty cool geometry. Oh my God, I just went to 0. It's going to be very unhappy with that. It's going to take a second to crash out on me. But that's it. You've got a pretty nice parametric node. I'll save this one as soon as we see the crash, and I will stop and play this video for those that want to see it. Thanks very much. Michael Wickerson at Wickerson Studios.